Welcome to my class Physics Untold. Here I am representing 200 puzzling problems, and this is problem number 67. The question is, one end of a rope is fixed to a vertical wall and the other end pulled by a horizontal force 20 Newton. The shape of the flexible rope is shown in the figure. Find its mass. In this question, if we analyze the question, in this diagram, the one end of the rope is fixed and this end is fixed, which is mentioned in our question, and the other end of this rope, this is the other end which is pulled by a force of 20 Newton. The shape of the flexible rope is shown in the figure. This is the shape, and we have to find the mass of the rope. As per this diagram, as we are seeing that the shape of the rope is a curve. So if we draw a tangent on this point, so this is our point A and this is our point B. So if we draw a tangent at the point A on the curve, then the tangent on this curve looks like this. This is the tangent at the point A on the curve. And again, if we draw tangent at the point B, then tangent at the point B looks like this. This is a tangent at the other end B. Now if we measure the angle here, then if we use a protractor, or the figure can be used as the source of the information, because as we are seeing that the angle here is not mentioned in our question. So if we use the diagram as the source of information, then if we measure this angle by a protractor, then we can measure this angle is 30 degree. Let these two tangents meets at the point P, or P is the point of intersection of the two tangents, tangent at the two end of the rope, and this angle is equal to 30 degree. Now if we draw the force component at the point A and B, then we can draw the force component as so the mass of the rope is acting in downward direction. So at the point A, the mass component or weight component acts in the downward direction, and its normal reaction will act in this direction. So this is our weight, that is equal to mg, that is equal to w, which is equal to mg. This is the weight component, and the normal reaction, which is equal to the applied force here, which is equal to 20 Newton. It is also mentioned in your question. Therefore here this normal reaction will also balanced with this force, or we can write here this normal reaction will be equal to 20 Newton also. So this is a 20 Newton force, and this is the tension force, and along the tangent there is a tension force. So we can write here, this is our tension force, and also this is in this direction there is a tension force, or there is a tension force in this direction or in this direction also. So this is the directions of the tension force. So if we divide the tension force into components, then we can write the components of the tension force as, if this angle equal to 30 degree, then this angle is again equal to 30 degree, and the vertical component or this component of the tension force must be equal to t cos 30 degree, must be equal to t cos 30 degree, t cos 30 degree, and the horizontal component of the tension force should be equal to t sine 30 degree, t sine 30 degree. So if we balance this equation, then if we, as the rope is in equilibrium, therefore you can use the condition for equilibrium. The condition for equilibrium is summation of fx equal to 0, and summation of fy, and summation of fy equal to summation of fy equal to 0. So from the summation of fx equal to 0 we can write, so x component of our forces is equal to 20 minus t sine theta, or t sine theta or t sine 30 degree minus 20, which is equal to 0. Or if you solve this equation, then we can write this equation as the value of t sine 30 degree, the value of t sine 30 degree equal to t sine 30 degree, which is equal to 20. Or we can write the value of t, which is equal to, value of t equal to 20 divided by sine 30 degree, or equal to 20 divided by half, or which is equal to 40. Or value of the tension force here, T equal to 40 Newton. And from the component summation of Fy equal to 0, we can write this equation as the force in the y direction is equal to T cos 30 degree equal to T cos 30 degree minus mg equal to 0. Or from this equation we can write mg equal to T cos 30 degree. Or we can write the value of m equal to T cos 30 degree divided by g. Now if we substitute all the quantities on the right hand side of this equation, then we'll get the mass should be equal to T. Now the value of T equal to 40 Newton multiplied with sine cos 30 degree, which is equal to root 3, divided by 2, and the value of G equal to can be taken as 10 or 9.8. So approximately the value of, now this 2 and 40, if we cancel the divide this 40 by 2, we'll get here is 20, and the value of root 3 equal to 1.732, and there will be 2 again. Or we can write the value of the mass, which must be equal to 3.464, or which is approximately or must be equal to approximately 3 point must be approximately equal to 3.5 kg. This is approximate mass or tends to exact mass because we take here the value of g as 10. Sometimes it is taken as 9.8. So approximate or its mass of the rope is 3.5 kg, which is the answer of the required question. Thanks for watching this video. Thank you.